In this video, I want to have a look at great circle distances. So a great circle is a circle on the surface of a sphere that has the same center, radius, and circumference as the sphere does. So that means if we were to, say, slice this sphere exactly in half, the circle that would be formed would be a great circle. Whereas if we were to slice our sphere, say, somewhere straight down here, the circle that we ended up with wouldn't be a great circle, because it's not the biggest circle we could have around that sphere. So it has to be that largest circle. So when we're looking at the Earth, the equator and all the meridians of longitude are examples of great circles. So the equator cuts it exactly in half across the middle, and all of our meridians of longitude, if we sliced the Earth exactly along the meridian of longitude, that would be a great circle as well. The other piece of information that you need to know is that the radius of the Earth is exactly 6,400 kilometers. So what we want to have a look at in this video is how we can find the shortest distance between two places on the Earth. So say we had a location there and we had another location up here. The shortest distance between those two will be this curved distance along that meridian. Now, so it's going to be the curved length that forms part of a great circle. So we're only going to look at locations that either lie on the same meridian of longitude or that both lie on the equator. So we're not, for example, going to look at locations like this and look at that great circle. We're only going to look at, like I said, meridians of longitude or ones that lie on the equator. But to find those, we need to look at the angle that they make, and we're going to use the arc length formula. So we're going to know the coordinates of our 2 points, and we're going to have to know what angle they are at from the center. So for example, this one might be at, say, 10 degrees north, and this one might be at, say, 70 degrees north. So that would mean this angle in the middle would be 60 degrees. So this here is what you have on your formula sheet. So we've got that the arc length of a circle is theta over 360 times 2 pi r, and we're also told that the radius of the Earth, we always use 6,400. So that means that our theta is going to be that angle that's formed from the center of the Earth, and our r is going to be our 6,400. So let's have a look at a few examples. So our first question asks us to calculate the shortest distance between city A with coordinates 35 degrees north and 116 degrees west, and city B, which has 12 coordinates of 12 degrees south and 116 degrees west. So because they both have this 116 degrees west, that means that they lie on the same meridian of longitude, which means they lie on a great circle. So what we're going to do first, it's always a good idea just to draw yourself a quick diagram, and we need to figure out what this angle in here is. So this is from the center of our Earth. So we know that city A is 35 degrees north and city B is 12 degrees south. We've got 35 degrees north and 12 degrees south. So that means this one is 35 degrees above the equator and this city is 12 degrees below the equator. So the total angle between them would be 47 degrees. So we'd add them together. We also know, again, that the radius of our Earth is 6,400 kilometers. So to find the length between those cities, the shortest distance, we'd have 47 over 360 times 2 times pi times that radius of 6,400. If we pop that all in our calculator and round to the nearest whole number, so the nearest whole kilometre, we'd end up with 5,250 kilometres as the shortest distance between those two cities. Our second example asks us to find the shortest distance between city P, which has coordinates 60 degrees south and 25 degrees east, and city Q with 38 degrees south and 25 degrees east. So again, they are lying in the same meridian of longitudes. We're all good there. We'll draw ourselves a diagram. And our diagram doesn't have to be accurate, but it's just to give us an idea of where our cities lie. So we've got 60 degrees south and 38 degrees south. So we're below the equator, so 38 degrees south would be here, and 60 degrees south would be here. So we've come down 38, and then we've come down all the way to 60. So that means because they're both south of the equator, we're not going to add them together to find this angle like we did in the first example. We're instead going to have to subtract them. So So we're going to go 60 minus 38, and that would give us 22 degrees in there. And again, our radius is still 6,400. So that means our length is going to be 22 over 360 times 2 times pi times 6,400. And if we round to the nearest kilometre, we'd end up with 2,457 kilometres as the shortest distance between those two cities. So that's just a few examples of how we can calculate great circle distances.